For all the other categories, so for persistent work, WorkManager and ForegroundServices in some cases are the recommended solution. So a constant in this, as I said, is WorkManager. So the official definition of WorkManager from Google Docs is the recommended library to perform persistent work. Let's examine all of those categories one by one. All right. So, hi everyone, I'm Paolo Rotolo, and I'm so glad to be here at Droidcon, Italy. And welcome to my talk, a guide to Android background work in 2023. So, a little bit about me. I'm an Android developer at a company in the south of Italy. And at work, I mainly focus developing apps with Bluetooth and to enable indoor localization. So we use Bluetooth to do indoor localization, and that happens in background. So I decided to give this talk to give an overview of all the tools that you can use for the various tasks that you might have to perform in background. Also, during the talk, we will see the newer API changes and also the breaking or behavior changes of the latest Android versions. Also, in my free time, I like to contribute to open source. I maintain some libraries like AppIntro. And in my other free time, I'm also a piano player. So you might say that I like to press keys on a keyboard, whether it's a computer or a piano keyboard. So let's start. As I said earlier, we have different type of work that you can perform in background. So we're going just to categorize all of them. So immediate work, as the word says, is the work that happens immediately. So it's usually user-initiated. Also, we have a long-running work, which is work that takes more than, let's say, 10 minutes to complete. And finally, we have deferrable work. So with deferrable work, well, it doesn't really matter the exact time in which you schedule that work, but you just make sure that the work gets done eventually on the OS in a window of time. Also, more categories. We can introduce persistent work and impersistent work. So to know more about persistent work, persistent work basically has a global scope. What does that mean? It isn't tied to any component of your application. So persistent work isn't tied to an activity. So it has to survive configuration changes, for example. It isn't tied to a view model or the app entirely. So it has to run even when the app, of course, is closed, if we want to do something in background. Also, for this reason, it might survive also process that, and even reboot of the device. Of course, when I say survive, I mean, of course, there is no process running when the phone is powered off, but at least you should, the operative system should know that it has to reschedule your work when the device comes on again. So now we're gonna take those categories and see how we can perform work with the tools available to the Android community for each one of them. So let's start with immediate. I've talked about scopes for impersistent and persistent works. So what is the first thing that comes to your mind when you think about scopes? Well, as an Android developer, for me, the first thing that comes to my mind are coroutines, because coroutines have to run on a scope. So in this case, we are running a coroutine in the view model scope. So we are saying when the view model is dismissed, so maybe the user doesn't have to see that photo anymore, well, just cancel off the work in that scope. So in this case, the coroutine will be cancelled, and this is not persistent work. In fact, we're cancelling it. So immediate impersistent work is just a fancy word to say async work. So you can safely use coroutines for that. For all the other categories, so for persistent work, WorkManager and ForegroundServices in some cases are the recommended solution. So I didn't insert Impersistent Long Running and Impersistent Deferrable because sometimes it doesn't make sense to have, for example, deferrable Impersistent work, because you're giving your work to the operating system, you're saying schedule it at in this window of time, and maybe your app will be closed in that time, so it needs to be persistent work. So a constant in this, as I said, is WorkManager. So the official definition of WorkManager from Google Docs is the recommended library to perform persistent work. So let's examine all of those categories one by one. Deferrable first. I will not explore all the features of WorkManager because you have the Android documentation for that, but we will just see what are the main differences between versions and just a bit overview of how this works. So this is a deferrable task. In fact, we are uploading logs to our backend. It might happen, it may happen at any time. It doesn't make sense to schedule it, for example, exactly at midnight. Should happen at night, let's say. So we have this function, which is a do work function, and this is a suspend function because we're using a coroutine worker that enables us to use coroutines. You can also use worker. There is a normal worker, or RX worker. There are many types of worker. So from this worker, from this method, do work, we have to return a result, and we can return success if the action we needed to run is done, or retry or failure to tell WorkManager what he needs to do. So how do we schedule this? This is the code. Because we have to do it every night, basically, we're saying the WorkManager, okay, use a periodic work request. And a periodic work request tells the system that it's a periodic. So given an interval, 24 hours, given a time unit, interval 24 time unit hours, the system takes care of enqueuing it. So what will happen in this case? Follow this scheme. So we have this repeat interval, and we have some window of work when the work can happen. But what if you want to really schedule a work that should happen at the exact millis in time? Well, you can use Alarm Manager for that. But, of course, you should use it only for important work. So it's called Alarm Manager for that, for example, for alarms. And so because it might distract the power cycle of the device, because if the device is sleeping, for example, you're basically waking it. So it's very dangerous to do so for a battery point of view. And also on SDK greater than 31, you are required to ask another permission to do that. So back to your our periodic work request. So if you look at this code, well, we might say that it's a little bit error prone because we're just adding a new request, and if by error this code gets executed again, we are queuing another persistent work request and so on. So there is another feature of WorkManager, which is unique periodic work, that lets you associate an ID, a tags, or a name to your workers. So you can use some policies when the work is already running or enqueued. And some policies are this. We have keep, we have replace. In reality, we had the replace because, of course, keep keeps the enqueuing task and doesn't touch it. Instead, replace replaces the task. But now, starting with WorkManager 280, released in February 2023, the replace policy was renamed in cancel and enqueue. So it is more explicit. You're saying your task gets cancelled and gets enqueued again. And also, another policy has been added, which is update. So with update, if you declare an interval in which your task will be run, basically you can say to the WorkManager, okay, just update the code, and at the next run, use the new worker that I've defined. So the enqueue time is preserved in that case. We'll see another example later, because I'm going to introduce you to another feature of WorkManager, which is observe the work that is happening. Now, until now, you had this live data for observing work. We are getting work in this case, for unique work, but you can use it with all the types of work, really. And now WorkManager also exposes flow, so you can collect it in Kotlin more. You can collect it in Kotlin if you're using Kotlin, of course. And inside this method, we also can get which is the next time that the worker will run. Of course, it's not the exact time. Again, it's just a window of time. So doing this can enable you to perform some advanced logic with another API also that has been introduced, which is set next schedule time override. So in this example, we're uploading some logs. So let's say that you have detected a critical crash. So you want to upload your log before the interval. You can just say, okay, override the next schedule time with this time that I'm giving you, an approximation of this time, and this will happen. It will happen that the next one will be included in the new time, and then the work manager will, from that time, go back to the original planning, basically. And also notice that I used update as a periodic work policy. So that was deferrable. Long-running work. For long-running work, as I said, we intend work that gets executed in more than 10 minutes. Let's say this example. So now we are doing basically location tracking. So we are in a while loop, and in coroutines we can do that. We can say, while the service is running, well, take a user position each second and give it to the backend. Okay, so this, how long will this worker work in background? We're using a normal worker as the one we used before. Well, to answer this question, we have to see what happens in behind the scenes of WorkManager. And what happens behind the scenes is this. WorkManager is using on API 23 plus JobScheduler to include the work, and using a lower version of Android, a combination of Alarm Manager and Broadcast Receiver. So, because our min SDK might be greater than 33 or 23 this year, you might say, okay, so why are we using WorkManager? Why don't we use JobScheduler directly? Well, there are some things that device producers like some companies do, which is on lower-end devices, maybe if you have the apps in the recent section of your phone, when you dismiss them, just kill the process to preserve battery. And of course, it is good for the user, maybe, but this is bad for us that we want to run work in background. So WorkManager keeps you covered in this case, because he has some classes, he has a lot of optimization really, but he has some classes, if you look at the source code, that will see if your process is killed, for example, and in that case will be requeuing that work that you might lose in that case. So yeah, use WorkManager for that and not directly the API, because they are more optimized, they have more feature. Also, another thing of WorkManager is that he has a greedy scheduler that runs when your app is foreground. So if the user is actively using your app, the task will be scheduled by this greedy scheduler, which is a class in the WorkManager library. There's no need to give your work to the OS if your app is running. So we were saying, job scheduler, how much will our work run? So if you search on Google on Android documentation, you see that it depends on Android versions. Lollipop and Greeter, we have 1 minute of running for jobs. And with Android M, we have 10 minutes. And with Android S, instead, we have 10 minutes, but the work might run a little more if the system is free, let's say. So maybe the average is 20 minutes. That's because I added 20 minutes in this slide. It's not so easy, because this isn't the only constraint in this time, because you have to know also about app standby buckets. So Android basically takes all the app on the device, starting from Android 9 in reality, takes all the apps and categorize them into some categories, which are based on the usage of your app. So there are a lot of other restrictions, but from the point of jobs that run in background, we can say that more the app is rarely used, more restriction you have. So it depends on the bucket you are in, how many minutes of work you can run in background with JobScheduler, with a normal worker. So a solution of this, the last case is restricted because the user can restrict your app also for optimizing battery. So to solve this problem, you can switch to ForegroundServices. And the great news is that ForegroundServices are integrated with WorkManager, so it is just one method change. And you have to call set foreground in your worker. And you also have to pass an object foreground info, which is basically a notification, because we are performing, we are running a foreground services, so the service will be in foreground, and that means that you have to notify the user that a service is running, so you have to provide a notification for that. And you can also add to the notification buttons and to trigger some intents and so on. So a little API changes in those years about foreground services. Starting from Android 10, you have to declare in your manifest if your services uses danger permissions, for example, microphones or location. This has changed with latest version of Android, so now you have to declare everything. So not only dangerous permission, but you have to say basically what your foreground service will do. And you also have to ask the required permission, which is foreground services, and then underscore the name of the type of the foreground service. So now you have all of those types for every type of work that you might do in background. So make sure to define those in Android manifest. And as you can see, there is also media playback, health. There are some new permissions that you require to ask. And those are really normal permissions, so the user won't be asked to approve it. It will be approved by default at runtime. Of course, you have to ask also location permissions, precise location, of course, location. So other API changes. Starting from Android 13, we have this new UI, which is called TaskManager. So now the users of Android can manually cancel the work UNQ. So if they go in this section, which is work that happens in background, they can just stop your app. And of course, you have to be prepared for that. Again, as we said with JobScheduler, why aren't we using foreground service directly also for this? Well, this time you might use it for some use cases. For example, those use cases, because when you have to interact with your service from an activity, for example, foreground services lets you bind the service to the activity, so you can just call the methods from it, so it's more easy to interact with it. So it might be good for some use cases. See instead WorkManager as a library that given an input, which is the input you pass to the WorkManager, basically performs some processing. In this case, you can interact a little bit more. Other API changes that are specific to the foreground services. Well, if you're using directly foreground services, you might have to migrate to user-initiated data transfer jobs if you're doing data transfer. So now you can say to the OS, those are the constraints that I want. Maybe I'm connected to Wi-Fi, or I'm on a not metered network. And those are also some estimators of the sites that my transfer is about. So you can use that. Or you can also use WorkManager directly. It's the same thing. Android 12, Android 12 also loosened some restriction because, oh no, that was the slide after, sorry. I will talk after about that. Android 12 also remember the buckets that we've seen before. You cannot schedule foreground services if you are in the restricted bucket. And also, you cannot launch foreground service if your app is background. So the user has to do an action on your app to start foreground services. But for this, we also have some exception. The exceptions are, as in our case, if you're working with a wearable, for example, and you're using Companion Device Manager, well, then if a link is established with a device, a Bluetooth device, you can then start the foreground service from background, because maybe you have to sync data or manage the status of the link. Also, you can do it if you're receiving a geofencing event or activity recognition event. For example, you are recognizing that the user is biking, and in that case, start activity recognition, start tracking its location. And another important thing is that you can do that if you receive on Firebase messaging cloud, Firebase cloud messaging, sorry, high priority notification. So you basically have two types of notification, normal and high priority. And high priority notification are associated with notifications that are really shown to users. So maybe a message, maybe an important thing. So if you do that, you can schedule work in background as a response to that. But of course, again, this will be used only for important things. And if the Android operating system knows that you are abusing this API, so you're not showing anything to your user, and you're just exploiting it to start working background, well, it will downgrade the priority of the FSCM notification. And you can actually listen to that. You have the original priority, the one that your backend sent, and the priority that the notification finally had. And there are really some other exceptions that you can see on the Android documentation. But another important one is that if the user removes your app from background optimization, well, you can run anything. So again, this varies on the vendor of the device, but at least on Pixel devices, you can just ask if you really want the user to disable battery optimization for some feature. If the user is okay with that, you can basically do almost a little things more, let's say, in background. So that was a long running. Last one, immediate work. So we are already seen in persistent immediate work with coroutines. For persistent work, again, we use WorkManager. This is an example. So now we are sending a message. Maybe it's a chat app. We have to send a message. We have to upload an image. And why is this persistent? Well, because if I send a message and maybe then close the app on the power of my device, I want the message anyway to be sent when the device is on again. So for now, it's persistent work. So to do that, you can use another feature, which is expedited work. The features of expedited work are important because expedited work are related to work that is important to the user. It's user initiated. Are speed, because they usually complete in a few minutes. They are not long. Then we are quotas, because each app has a dedicated quota of time, of course, in which it can run expedited work. So when you run out of quota, you can just do it anymore. Power management, because expedited work also in dose mode. So even when there are some power management features on, your expedited work will run anyway. And lastly, latency, because as soon as you schedule an expedited work, it will run. So to use that, again, it's just one method. When you include your request, you just add set expedite. As we said earlier, you can define then a quota, a policy that defines what will happen when you run out of quota. And this time, we're saying the work manager, okay, don't dismiss it, just run as a normally work request, so using a normal worker. There is another thing that you have to be careful in this case, which is you have to override this method, which is get foreground info. Why? Again, because we have to see what happens under the hood of WorkManager. So expedited work is a new feature of JobScheduler, again, which is available only on Android 12 and plus. Below Android 12, the WorkManager still runs a foreground service on your behalf. So if it runs a foreground services, it needs a notification. So if you don't override this method, your service will crash on Android 12 below. And that was all for Work Manager. What is the next step? Well, you have implemented all the work you required in your app. You have to debug why things maybe doesn't work the way you want. And Work Manager gives you some tools to do that. You can enable verbose logging, I think it's called, that will log some verbose info in the logcat. And you can also use some ADB commands to let you print the status of all the jobs included in job services, for example, in JobScheduler, sorry. But let's say that most of the times, some error doesn't happen on our devices, on the devices used by the people who are developing, but happens out in the wild, maybe on a strange device that a user is on. So what can you do in this case? Work Manager 290 Alpha 2, which was introduced, I think, always this year, enables a new feature, which is stop reason. Basically, you can ask your worker, so why has the worker stopped last time? So what is the stop reason of latest enqueuing stop? And if you look at it, we are not just asking the stop reason always when we listen for updates from that work. We are doing it just when the work has been already stopped. So when run at count is greater than 0, and if the work again is enqueued. So in this case, you will have the exact stop reason for that. And you can also do it in your worker directly, so in your method of do work. So those are some stop reasons. You can see that, okay, of course, not stopped will be returned each time the work has not stopped. But then maybe some constant changes. Maybe the user itself killed your app, so you have stopped by the user. Maybe the device is going to sleep. Some other things you can debug that and maybe log it to your backend. And if you want to know more about that, because we don't have a lot of time, there is an article on Medium that I wrote about this that examines each of the conditions. So this is the QR code for the article. Also, as I said earlier, it is not that simple. There also are some policies enforced by OEMs that will affect your background work. And for that, I can suggest you another talk that was presented at Droidcon London last year by the team of Urban Droid. So they made a Sleep as Android app. I don't know if any of you used Sleep as Android. It's a sleep tracking app. And of course, it runs in background at night while the phone is still. So it's a very difficult use case. And if you look at this talk, you'll find out that they created an interesting website that is don'tkillmyapp.com. And it's basically a letter to all the different vendors saying, okay, this is the rating we give to you. And so you can have thumbs down, but you can also have other icons to see the rating. You'll find them in the website. And also, this is a website that educates its both developers and both users. Because for each vendor, you can see a section dedicated to developers that say all the different things that you can do to mitigate that. And also different settings for the user. So you can redirect your user to that to say, okay, maybe disable that or just adjust this setting if your app isn't working the way you want. So that's all for me. Any questions?